Now we know how to calculate the lot size and the safety stock. And let's see how it affects our inventory management and the KPIs we can expect from this policy. Up here we have this graph we used to have where we see the evolution of our physical inventory and of our inventory level in blue. And back here, down here we have the very same graph, but with a larger, actually with some safety stock, which is the shadowed area here. So these two graphs are exactly the same, but for one thing, that this here has been pushed up this amount, which is what corresponds to the safety stock. So what we have here is that what we had as a stock out in this part of the graph, since we have this buffer, this no longer is a stock out. So what we get from having safety stock is that the chances of having a stock out is a lower, and that doesn't come for free. We have some price to pay, because now the average inventory has increased. These lines here, the red line represents again the physical inventory. So on average, it behaves as if it went all the way from Q to 0, Q to 0, and so on. Sometimes will be a little bit above 0, and sometimes will be a little bit below 0. But on average, what we have is a graph that is similar to the one we have for the economic order quantity. So the average stock here is half the lot size. When we have a safety stock, as it is the case here, we are having that same amount of physical inventory plus a safety stock which is always there, or it's pretty much always there. Sometimes we will have a little bit less than safety stock, some other times we'll have a little bit more. So the impact in terms of inventory is that the average inventory is half the lot size plus the safety stock. So the larger the safety stock, the more expensive our policy will be. But in exchange, the less likely will be the possibility of having stockouts. And this is reflected in our KPIs. Because now, to summarize our policy KPIs, if we use a reorder point where with the possibility of meeting all our demand is 97.7%, our reorder point, as discussed in previous videos, is 450 computers. We will order computers in lot sizes of 500, and that means that our safety stock is 200 computers. Remember that it was the demand due the lead time plus the safety stock. Okay, so this 450 is computed as 250 plus 200 computers, and this means that we will meet all our demand in 97% of our cases. So let's see the costs. How many orders will we have per month? If we are facing a demand on average of 1,000 computers and we buy 500 computers every time we place an order, we will have 2 orders per month. So our ordering cost will be twice $4,000, which is $8,000 per month. And the holding cost, we can calculate it as the average inventory in hand times the cost per computer and month. But now, our inventory, the average inventory has been increased exactly in the quantity equal to the safety stock. So the average inventory on hand is half the size of our lot size plus the safety stock, which is this 500 divided by 2 plus 200, which is 450. So the holding cost is now 450 times 32, which is $40,400. So this term here, this 200 times 32, when we calculate the cost, is the increase of having this safety stock compared to the one we had when we were dealing with a deterministic situation. So we have now a way to calculate the impact in terms of cost of having to deal with the uncertainty. So this is how the reorder policy works. We actually introduce a safety stock, which depends on the variability, and we pay for it here. So if we want to increase the possibility of meeting all our demand, we have to pay for some extra safety stock here.